For question 2, we have another formula. And this formula is looking at the amount borrowed. If you're borrowing money to buy a car, to buy a house, that's your present value. You make regular payments again, which are R. You have an interest rate per compounding period, just like before. And so as opposed to how much money will I have if I keep putting away money, this is going to figure out how long is it going to take to pay for my car? How long is it going to take to pay for my house? How much do I need to pay each month in order to pay things off? So the example that we have here, we're going to do both of these. We're going to start with the car, because most likely you'll buy a car before you'll buy a house. Person borrows $15,000 to buy a car. What kind of car did they get? Not bad. Pretty good one. Okay. You can afford to pay $300 a month. You get 6% interest rate from the car company, compounded monthly. How long is this going to take before you can pay it off? So again, we write down the formula that we're given, and this formula would be given to you. You're going to have to, when you do the questions in the textbook, you're going to have to flip back to see the formula each time. But on the exam, they're going to give you this formula. And you need to plug in everything. So you borrowed $15,000. So the present value of the loan is $15,000. You're paying $300 a month. The interest rate is 6% compounded monthly. We want to figure out how long it's going to take. And so we're solving for n, the number of monthly periods. Again, we do the same thing as before. We're going to multiply both sides by 0.06 over 12 because we want to get the power all by itself so we can use logarithms. 15,000 multiplied by 0.06 divided by 12 gives us 75. Divide both sides by 300. And now I don't need those big brackets. Subtract 1 on both sides. Now when I subtract 1, does it make sense that that negative sign stays in front? Because we had 1 minus. So that negative sign would stay in front here. And I still don't have my power all by itself because of that negative sign. I could multiply both sides by a negative, and now I have the power all by itself. Once we get that power all by itself, now we can use our logs. We can take the log of both sides. The negative n would come out in front of the exponent. And to get n by itself, we divide by negative log 1 plus 0.06 divided by 12. Type this into our calculator exactly as we see it. log 0.75 divided by negative log 1 plus 0.06 divided by 12. $57.68. So because it's a word problem, we need a statement at the end. It would take 58 payments. Again, we're going to use our calculator's program to check if this works, if this is the same answer. So again, your program is nice. Go to Apps, Finance, TVM Solver. We want to solve for the number of payments. I'll just put a 1 in there for now. The interest rate was 6%. In this case, they're giving you the car. You don't put it in your pocket like money, but you imagine they're giving you the car, and the car is worth $15,000. So at the present value, we put in $15,000, and because you get it, it goes in as a positive number. Next, you're making payments of $300 a month. That's money coming out of your pocket, going to the bank. That goes in as negative. The future value of your loan should be 0, because in the end, you don't want to owe anything. How long is this going to take? We go up to n, alpha, solve, 57.68. So how much did you end up spending on this car? Right? And you can do math in here. So for example, I can just use this line and I say, well, if I would have to pay 57.68 300 times, how much did I spend on this car that cost me $15,000? I end up spending $17,304. So the bank or the car company, whoever is financing you, is getting another $2,000 from you. Just save up money and buy it. Okay? This is how a lot of places make tons of money. A very common one is we have a sale on a TV price that is too good to be true. So you've got TV that's regular $5,000 for $2,000. So people are lining up to get this TV. And then they tell you, you don't even have to pay for it for a whole year. Have you ever seen ads like that? Don't pay for it for a whole year. Buy this TV now, don't pay for it for a whole year. Okay? So they give you the $2,000 TV. What they don't say is after the year, you have to start making payments, but you only have to make small payments. You only have to pay for it over 5 years. So they're saying it's $2,000. They don't tell you that the interest rate they're going to charge you after is 18.9%, like a credit card. They say you can, after the 1 year of not paying for it, you have to pay for it over 5 years, so 5 times 12 is 60 payments. And they say compounded monthly, and now if I go alpha solve, they're telling you, and then after that you just have to pay $50 a month. So that seems cheap. I don't have to pay for a year. I get a $5,000 TV for $2,000. I don't have to pay for it a year, and then it's only $50 or $52 after that over the next 5 years. Well, how much money did they end up getting for that TV? They still get $3,120 for that TV. You think you got such a good deal, but you're spending an extra $1,000 on it. Okay? And 18.9% There are some places that'll charge up to 30% interest. So you have to be really, really careful. Credit cards have quite a high interest rate. So the problem with a credit card, the good thing about a credit card is if you can pay for it, you never have to pay those interest rates. And you only have to pay for it at the end of the month, right? So you don't have to pay for it right now. So you're technically, the money you have can be making you a little bit of interest if you have it in a bank account, and you pay for it at the end of the month. But as soon as you pay interest on your credit card, you're paying a lot more. I read a statistic that, and I don't have the numbers right off, but how much does the average American person pay for every $100 on their credit card? So every time they spend $100, the average American, how much do they end up paying for that $100 item? And it was really scary. I think it was something like $300. 3 times the amount. Every time they put their credit card, you should tell them, you know, you're going to end up spending 3 times that. This is just compound interest stuff. This is just interest rates. Economics, this is sort of like personal finance kind of ideas. So when you go to put something on your credit card, if you don't have the money to buy that, you have to think, am I willing to spend 3 times the amount for that? Because that's how much I'll probably spend by the time I'm done paying it off. Then don't do it. Because chances are if you don't have the money for it now, you're not going to have the money for it next month. But the scary thing about credit cards is it doesn't matter if you have money or not. Yay, you get it. Yay, you get it. Yay, another thing. And it's like, oh, I want something else. Yes.
So do you feel it would be smarter to get a credit card?
Well, there are positives. If you can manage a credit card and you can pay it off, what that does is it gives you a credit rating. And that credit rating is used for later on to determine whether or not the bank is going to lend you money to buy a car or not. If you've never had any credit history, the first time you go to buy a car, they're like, I don't know if we can lend you the money because you have no credit history. But if you have a good credit history, then they change their interest rates. So if I go to buy a car and you go to buy a car, they might offer me a better interest rate than you because I have a better credit rating over the years that I've done things. What's that? Well, it comes up in math classes. We get it right now. I'm going to show you we're not going to do the formula, but we're going to look at the question that was set up here. Because, I mean, this is really useful stuff. You are going to buy a car. Most people are going to buy a house. Person wants to borrow $200,000 to buy a house. And they can afford to pay $1,500 a month, 4% annual interest, compounded monthly. How many monthly payments will the person make? So we go in here. We want to solve for the monthly payments. I'll just put a 1 in there. 4% interest. You get the house. When you buy a house, you get the house. So we put in here the 200. You get $200,000. You don't put the house in your pocket like you would do with money, but you get the house. It comes to you. It's a positive value. They can pay $1,500 a month. We put that in as a negative value. In the end, you want your future value to be 0. For this question, it said the payments per year are 12 and the compounds per year are 12. In Canada, for mortgages, they're not allowed to compound 12 times a year. They're only allowed to compound twice. Okay? But if we go alpha solve here, it's going to take 176.63 payments to buy that house. How much did the house cost you? 170.63, I'll do it, times 1,500, because those were your payments. Okay? You gave the bank an extra $65,000. That's a lot of money. Okay? knowing interest rates can be huge. So when you're buying your house, I'm going to say, okay, first of all, in Canada, let's do this as a Canada example. Let's make it compounded only twice per year. How much of a difference does that compounding make from 264? We now have only 176.10 payments times 1,500. Basically the same. Maybe a couple $100 less. But when you're getting your mortgage, if you fight hard and negotiate with your bank and you can say, get 3.5% instead of 4%, how much of a difference would that make? So right now the house is 264 that you would pay for it. Now you're, instead of 171 payments, it's only 168 times 1,500, from 264 to 253. $10,000 over a 0.5, right? You should be arguing for more 0.5 marks. This wasn't an E2 error, Mr. JR, because those 0.5s can be huge in some situations. Well, interest rate on houses is based on prime, and I believe prime right now is at 3.5%. Let's check out prime. Not prime. Prime rate in Canada, 2019. Prime rate 3.2% in December, 3.95 right now. 5-year variable mortgage rates are at 3.25. 5-year fixed mortgage rates are at 3.34. Interesting. So let's use that prime 3.95. This is so it's about 4% right now. Now, there's two types of mortgages that you can use. There are fixed mortgage rates and variable mortgage rates. What a fixed mortgage rate is, you decide it's going to stay at that interest rate for the next 5 years. And mortgages are always renegotiated after 5 years. So if interest rates go up, it's going to go up for you as well. Usually, a fixed rate is quite a bit more, like I've seen it as much as 1% more than a variable rate. The scary thing about a variable rate is that if it goes up, your interest rate goes up. If it goes down, though, your interest rate goes down. But it's a little bit more risky. In the past, I would say in the past 30 years, the variable rate has always outperformed the fixed rate. But people are still scared of it, so they go towards the fixed rate. Because if you can have your interest rate smaller, especially at the beginning, because the beginning is when it's worth the most. So a couple of things that can happen with this program that are really nice. Most likely you're buying a house. Let's do, I think a good starter house now in Winnipeg is not $200,000. You can't find that anymore. A good starter house is probably around $350,000. So let's do a $300,000 house to start. And most people pay their mortgage over 25 years. So if I go 25 times 12, that's 300 payments. So let's look at 4% compared to 3%. What this program can do for you is tell you how much are you going to pay a month. This is more likely what's going to happen rather than figuring out how many payments you're going to make. Because mortgages are almost always compounded over 25 years. You pay for them for 25 years. You buy it when you're 25, it's paid off when you're 50. Whew. Okay? So we go alpha solve, and it says it's going to cost you $1,600 a month if you want to buy a $300,000 house at 4%. So we can go up here and say 300 times 1578.06. Wow. That $300,000 house is going to end up costing you, did I do that right? Did I type in a number wrong? Let's check it again. 300 times 1578.06. Yes. You're going to spend an extra $170,000 to the bank for your house. Now, the positive thing is that houses increase in value. So chances are that 25 years later, your $300,000 house will be at least worth the $470,000 you paid for it. So you're not necessarily losing money that way. As opposed to a car, how much is your car going to be worth in 25 years, the one that you have right now? Probably nothing, or next to nothing. Okay? So that is the interest rate at fixed. If you went with the variable and it happened to stay at 300 payments, instead of paying $1,578 a month, alpha solve, pay $1,419 a month. An extra $150 less. If we look at how much the house would cost you at 3% times 1419.74, 425. There's 50 grand in 1%. Okay? The other thing, and this is where I feel like for myself, I've saved a lot of money over the course of paying for our house, is when you buy your house, most people buy the best house that they can afford, and you buy it when you're young or younger, right? You're just starting your job. And what happens when you're just starting your job? Your pay is at the lowest that it's going to be, right? For a teacher, teachers get a raise every year for the first 10 years that they're teaching. And then when you're old like me, you don't get raises anymore. It just stays the same. Okay? But I got a raise every year for the first 10 years that I was teaching. And that raise was about $2,000 to $3,000 a year. So after 10 years, you're making $20,000 to $30,000 more a year than you were when you began, which is a lot. Well, it meant that at the beginning, I could afford to pay $1,400 a month, or this case, $1,420. But then after a couple of years of teaching, I'm making more money. And so instead of going, woohoo, buy new shoes every month or something like that, I said, I'll take that extra money, because I'm used to living without new shoes every month right now. And instead of that, I'm going to put that money towards my house. Right? What did we have? We had $425,000 of this costing in the end. What difference would it make if I took, you know, an extra $200, an extra $300 and put it against my house? So instead of paying $1,419, I put $1,700, an extra $300 a month. Okay? I went up here, and instead of 300 payments, I knocked it down to 232. Well, what's 232.54 times 1,700, right? The house that was originally 470, we got down to 425 with 3%. We put a little bit of extra money against our house, and now we save another 30 grand. The house in the end is $30,000 left. So we were at $80,000 less just with a couple of choices all the way through. Okay? Then I found I found a place that let me pay, instead of paying once a month, I paid every 2 weeks. So that would mean I would make 26 payments a year, but my payments were half negative $850. Okay? How many payments would I make then to pay it off? 453. That number is bigger just because we're making them every 2 weeks. But now if I figure out times that by 850, instead of 395, it's 385. So paying the same amount but every 2 weeks instead of once a month, that saved me another 10 grand. And the reason the amounts get so big is because it's over such a long period of time. Now, paying every 2 weeks means you make 26 payments a year. If you pay every month, you would make the equivalent to 24 payments a year. Every 2 weeks gives you 2 extra payments, and some months suck because you have 3 payments in a month. But if you could manage that, again, it's another $10,000 that you would save. If you compared to our first number, 475 that we had up there, we've already knocked it down $90,000. Yes?
How much money did you save on your first house?
How much money did I, like, compared to if I would have kept things the same, I'm saying I would save $30,000 to $40,000. Okay, here you want to see something crazy. Okay, my first house. That's how much I paid for it. Okay? Do you know what that says? Old. Okay? And, okay, you ready for this? This is what my interest rate I negotiated. Down to 1.9. Okay? So, at 300 payments, I would have only had to pay 20, I went with the 26 payments per year. Oh, this should be 2. Compounding is only allowed to be 2. Right? I would have to pay alpha y equals only $265 a month every 2 weeks. What did I plan on doing? I paid $800. So instead of having to pay it off in 25 years, alpha solve, it would only take 92 payments. How much did that first house end up costing me? 92.47. Well, some of these numbers I don't remember exactly, but I'm just doing roughly here. I only paid the bank an extra $2,500 in interest, so I felt good about that. Okay? You know what's the crazy thing is sometimes the interest rate even went down. I think the lowest it ever went, because I picked the variable, it went down to 1.5 at one time. So that was really, really fortunate. Now I want to show you something, and I would like you to go home and ask your parents about this, or ask your grandparents, what are the highest interest rates they remember for paying on mortgages? Because there was times, Personal advisor for buying your house to save you money? Because in the 1980s and 1990s, interest rates for houses skyrocketed. So let's say I'm buying this same house in the 1980s. They went up to 18%. Okay? So now, 300, if I'm going to mortgage it over 25 years, I'll go back to paying monthly. How much would I have to pay a month to buy this same house in the 1980s? Alpha solve. I would have had to pay $1,000 a month over 25 years for that house. How much would that house have cost me in the 1980s? 300 times, and this is the power of interest rates, Wow. $314,000 for a $71,000 house. So because of that, what happened? People decided to sell their houses because they couldn't afford to pay the interest rates to buy them. What happens when a bunch of people decide to sell their houses? The prices go down. The value goes down. And then people with money scoop them up for cheap because they don't have to pay the interest rates because they have the money to do that and make even more money. So ask your parents and grandparents about interest rates, highest they've ever had, lowest they've ever had, what they're paying right now, right? With your house, do you feel like, you know, how have your parents, have they changed how much they pay for their house, or have they kept it the same since they bought it 15, 20 years ago, or whenever they bought their house? And maybe do a little bit of financial figuring, and maybe you can, right, for a new pair of shoes every month, you could save your parents some money, or whatever your fee would be. Okay, so questions from the second one are 7 and 12. And we'll take the last 10 minutes to work on those. We'll leave example 3, earth-shattering earthquakes, for this afternoon.